Welcome back, students. In our last video, we discussed three patterns of problems. In this video, we'll continue looking into one more pattern. So, just as a status check, we have completed all the theory part, and these are the problems. We are right now discussing sample and board problems around zeros and its coefficients, more particularly on quadratic polynomials. So, if you directly landed in this video, kindly check uh, video number 7 and 9, where I talk about the zero of the polynomial and zero of quadratic equation. Both these ideas are important to understand this video properly. So this is the fourth pattern of problem which we will be understanding. So the question could give you a polynomial and they will ask you to find the sum and zeros of the sum and product of the zeros. This is exactly the opposite of whatever we did in our previous pattern 3 in our previous video. So in the example or sample problem, we'll see how to find out the zeros and some of the polynomials. So if alpha and beta are the zeros of the polynomial, x square minus 7x plus 15, find the values of sum of the zeros, that is alpha plus beta and alpha beta, which is the product of the zeros. The solution approaches, first and foremost, you need to order the polynomial to the basic form. The quadratic polynomial basic form is ax square plus bx plus c. So you should order it in such a way that the x square term comes first, then you have the x term or the coefficient of x followed last by the constant term. So in this problem, it is already in the same form. So we straight away go for solving it. Sum of the zeros is minus b by a. The value of minus b is minus 7. So minus of minus 7 divided by 1 is equal to 7. And similarly, the product of zeros is c by a. C is 15, a is 1. So c by a is 15 by 1 is equal to 15. So this closes our problem. The second example, maybe you can try solving it. It's slightly tricky, not complex. If alpha and beta are the zeros of the polynomial x square minus x, find the value of alpha plus beta. That is the sum of the zeros. I think this was a board problem where the options given were minus 1, 0, 1 and 2. I'll just wait for a few seconds so that you can try solving the problem by yourself. So the solution approaches, I told we need to fix it or rearrange the polynomial to the basic form ax square bx plus c. So when you try to rearrange, you find the x square term, but there is no x term, and you have the c term, that is the coefficient. So there is no x term for this polynomial, so the value of b is 0. So sum of the zeros is minus b by a, which is 0 by 1 is 0. So this is your answer. Just as an extended solution, we can just find out the product of the zeros, which is c by a. C is minus 1. Minus 1 by 1 is equal to minus 1. So there's a small tip or caution which you need to have in solving this kind of problems. These are very straightforward questions and would look easy. But remember, they will make it tricky so that it's not so easy that you can grab that 1 mark easily. So one way or to stay safe is they will put the polynomial in a different order, like x minus 5x square plus 3, and you'll be tempted, the moment you see, you'll be tempted to solve it as minus b by a, where you consider this minus 5 as b and minus of minus b by a is 5, which is a wrong answer, because you need to first rearrange the polynomial to the form ax square plus bx plus c. When you rearrange, this minus 5x square comes first, followed by x and then 3. When you try to solve it, now the correct answer is minus b by a is nothing but minus of 1 by minus 5, which is 1 by 5. So You always need to rearrange the basic polynomial form and then solve this problem. The other way they make it complex is you find a missing x term or a coefficient term like how you saw in the previous problem. So in the next video, we will explore other patterns of problems. Till then, bye. Thank you.